In this video, we will learn about the derivatives, its introduction. By derivative, what we mean? The slope. And what is slope? Slope is the rise over run. That means if we have these 2 pointers, slope is equal to the vertical distance between these 2 pointers, which is denoted by, let us say, del y, upon this run, the horizontal distance between these 2 pointers, del y upon del x. Slope shows us change in y upon change in x. How much changes on this axis upon how much changes on this axis, on x-axis. This is how do we find the slope. But what about a single point? If we have a single point, let us say I have another graph, I have this point, what will be its slope then? If I use this very formula, here you can easily see that change in that means change in y is equal to 0. Okay, because at a point that vertical distance is 0 here, and similarly change in x is also 0. That means our del y is equal to 0 and del x is also equal to 0. And if I write slope is equal to del y upon del x for a point, here we can see it comes out to be 0 upon 0. Can we find out the slope in this way? No. We have what we call the derivatives. We use a small difference, then we shrink that very small difference towards 0. Okay, if I draw another graph of this, okay, let us say I have this is x-axis, this is y-axis. If I zoom this point, okay, let us say it is something like this. Okay, let me take 2 pointers on this line. Okay, on this curve, let us say I have these 2 pointers, and let's draw the a line between these 2 pointers. Now let us say when on x-axis we are at x corresponding to this, our y value is, let us say it is f of x. Simple thing, as x, sorry, the value of x is f of x, and let us say at this point x has changed to x plus del x. Okay, it will be greater than x obviously, and corresponding to this point, let us say our function will be then equal to x plus del x. Okay, simple thing. I have done nothing unusual. I have taken 2 pointers, I have zoomed this out for the sake of simplicity. When x at when we have x, our function is f of x. When we have x plus del x, our function is f of x plus del x. This shows us change in x, and this shows us change in y. Okay, if we use the formula, here you can see as x changes from x to x plus del x, our y has changed from f of x to f of x plus del x. Okay, so this change is being corresponded by this change. Then if we use this very formula, that is slope is equal to change in y upon change in x. Here you can see what is the change in y. So y has changed from f of x to f of x plus del x. So change will be this point minus this point. Okay, so we have f of x plus del x minus f of x. Okay, this denotes our change in y, and corresponding to this, what is change in x? That is x plus del x, final position, that is x plus del x minus this x. Okay, and which comes out to be equal to f of x plus del x minus f of x upon del x. This will be our slope formula. Obviously then what we do, we simplify it as best as we can, and then make this del x shrink towards 0. Okay, so if you are getting confused, let me give a simple example. Let us say I have a function f of x is equal to x square. Okay, now we change x from x to del x. Let us say we have x f of x plus del x. When x changes from x to del x, then f of x plus del x will be obviously equal to x plus del x square. Simple thing, let us solve this. Will become x square plus 2x del x plus del x square. Okay, a plus b whole square. And here you can see our x has changed from x to f of x plus, from x to x plus del x. Corresponding to this, our f of x is changed to f of x plus del x. Then slope will be equal to change in y upon change in x. And what is change in y? Change in y is this, that is f of x plus del x minus f of x. And what is the change in x? X is changed by del x, as I have explained it here. Or let me write it here. We have x plus del x minus x. Okay, now what is f of x plus del x? F of x plus del x came out to be this very function, that is x square plus 2x del x plus del x square. To this we subtract the original function, that is x square, and divide it by this. So this x and x gets cancelled, we get del x. We simplify it again, so this and this also gets cancelled. We take del x common, we are left with 2x plus del x upon del x. Okay, del x again gets cancelled, so we are left with 2x plus del x, which is our slope. Okay, now what we do here, we do one thing here, we shrink this del x towards 0. Okay, if our slope is, that means if our del y upon del x came out to be 2x plus del x, we shrink this del x towards 0. When we shrink it towards 0, our slope will be equal to, so this term will become 0 and our slope will be equal to 2x. That is to say, the slope of this function x square is equal to twice x. Okay, simple thing. Slope is nothing but change in y-axis upon change in x-axis. We have used this very formula to derive this the slope formula, and I have explained it with an example. Okay, I hope I make myself clear. Thank you.